So first of all, for this one, I think it's very helpful to set up your raw data again in the first tab. So we should have 32 different quadrats. Our sites, we had old growth and secondary forests. Then we had in the old growth we had beech and maple, and then the secondary we had beech and oak poplar. And then we had either under a tree or away from the tree. And then you have probably a lot more species than this, or maybe fewer, I don't know. But I put 5 here. Some of the most common ones, and then a few rare ones, some self-elected or trillion. Those would be considered rare ones. So yeah, get those down first. And the first thing we're doing is diversity, right? So we've calculated this a few different times now. It's going to be the same thing. The way I did it was I literally copied and pasted everything from that first tab. And what do we need to get proportions? Because we need to figure out the proportions first, right? So we have to get the total number of individuals from each quadrat. So I have a column against all the total individuals. And then we have to calculate the proportion of those and then square it, right? So that's what these are. And you guys have done this before, so I'm not going to go too slowly here. But let me know if you want me to slow down, okay? So these are all the proportions. And then from those, you can calculate diversity. So again, 1 would be the sum of the proportions squared. So what this is these are the proportions squared for each species. And you take 1 with the sum of all these. So now you have a diversity for each individual quadrat, right? Because each of these rows is a quadrat sample that you took. So at this point, what I found was very helpful was after you figure that out, you don't really need any of this other stuff anymore. So I'm not going to delete it, but I'm going to hide it. You guys know how to do that? Oh wait, I was screwing up. Because really all we're concerned about now is our diversity. So I'm going to hide this. And now we have our diversity next to all of our sites and stuff, right? So for the next stage, so we've already calculated some diversity indices for each of these 4 things. First, we're going to compare the ones that are under the trees directly. So the under maple quadrats, the under beech quadrats, and under beech quadrats from the secondary forest, and the under poplar quadrats, right? According to the sheet, that's what you want to do first. So first, calculate the average diversity for each of these. So the beech and the old growth, this is the average diversity of the beech and the old growth with its associated standard error. This is the average diversity of the old growth maple away from the tree, associated with error, and so on. So each of these quadrats should have 4 different, each of these different things should have 4 different quadrants, right? So you're taking the average and standard error of those 4. Is that clear? Okay. I said it confusing, but I think you guys can follow. So now that you have all your averages, what you just need to do is pick out the ones that you want to compare. So for this first one, we're going to compare the old growth forest under beech and under maple. So that's over here. Old growth forest under maple, old growth forest under beech. So it's these. So it's 246 and 242. Which you see here. So you just have to kind of go through and pick out the ones that you're choosing to compare and put them next to each other. And then it's just a matter of again, arranging your data in the correct manner to where you look at a graph. So in this case, you want to arrange it where you have old growth over here, secondary, and then under beech, under maple, under beech, under oak, and then you just select these things. That, and that was a million times, but you get that. And you throw in your secondaries. Okay? So that was this part, the make a bar graph for the new diversity index on the y-axis, and for plant conditions on the x-axis. Then you want to use a one-way ANOVA to test for significant differences between the 4 under-tree quadrats. So to do that, we go to master stats, and make sure you plug in the right stuff. You guys want me to walk through that, or are you comfortable with using master stats? So again, like the average here, this would be one of your data entries, would be another, and then these as well. So I'll do it real quick and show you. ANOVA. One way. And then we're comparing 4 different things. So your initial setup and we're samples before. They're independent samples. You have 4 columns here. And those will be the 4 things you compare with your bar graph. In this case, the ones that are written here. All from the old growth, old growth maple, old growth beech, and then secondary beech and secondary poplar. So you should end up with something like this. And with this big data, it did show a p-value of 0.015, so there's a significant difference somewhere in here. Remember, within ANOVA, it doesn't tell you which ones are different from which. It's just telling you that there's a significant difference within this box. But as you can see, it's most likely, since these are similar and these are similar, it's most likely there's a difference between these and these. So you can look at the data and tell what's going on. For the second part, you want to make a graph. This time it requires a clustered bar graph. And we're comparing different things. So this time we're comparing away from the tree to under the tree. So what I did for this case was I took all this data and I copied and pasted it down here. And then I just resorted it to get it how I wanted it. Because here it's sorted by away and then under, and then see how old growth and secondary, old growth, secondary. Here I sorted by site first, so all old growth, and then all secondary. That's just because if you resort things, sometimes it's easier for to work with it, so just keep that in mind. If you do a cluster bar graph, you want to structure it this way, where you have the way the clusters together would be, so your columns would be away clustered and then under clustered, and then your 2 separate things. So these are just the 4 averages. So up here I have the 4 averages in the same column. Here I separated 4 averages across 2 columns to get the clusters. So again, we have away, and then we beech maple and so for this one it says combine all quadrants for each category. So we have old growth and secondary are separate, and then the same thing for under the trees. And then looking at those, it has to do a t-test. You can also create your standards. You guys remember how to do t-test in Excel? You can do them in master stats too, but it's so simple in Excel that I just recommend sticking with that. Just do it on the spot. Basically, it's formula t-test, and then you have 2 ranges. The 2 ranges that are selected for the old growth versus secondary are, and this is why I reordered these. So I have all old growth together and all secondary together, so I can just select those 2 ranges. And then you end up with a t-test, and yours would be 2 tails and type 2. So you have a range, and then 2, 2. And you end up with a Alright, so a very significant difference there. And then you do the same thing for under versus away. Except you're selecting, these are all away, these are all under. And now it shows there's not a significant difference, right? It's above 1. so that's informative, right? It's telling you there's no difference under the tree versus away from the tree, but there's a huge difference when you go from the old growth forest to the secondary forest. What do you want to see? Yeah. I don't think it's being blown up, but yeah, so it's just t-test, and then you put in array 1 or range, and then you put in the second array or the range that you want to compare. So you have 2 ranges that you're comparing, and then it's just 2, 2. Okay? So keep in mind what you're measuring here too, right? These are all diversity indices. So I'm just telling you there's no difference in diversity between under and away, and there's a huge difference in diversity between 2 sites. Okay? Because what you're measuring is always important. All right, so that's the diversity analysis. Let's go to similarity. So on the second side. We're going to be computing a new thing here. So right now we're going to be looking at presence absence. All right, so you've got a presence absence data too. It's basically if there's a 0, it wasn't there. If there was a number, it was there, right? So really easy. So for the purposes of this, I just use 1s for presence and 0s for absence, okay? And I just went through and I just filled it all in myself, transferred it all over. So I basically copied and pasted it and then transferred these all to either 1s or 0s. So we're using the source and the similarity index to see how similar these things are. If you look at this equation, the way you compare is you need to know what these 3 variables are, A, B, and C. A is the number of species that is common to both sites of what you're comparing. B is the number of species that are inside B but not inside A. And then C is the number of species that are inside A but not B. So make sure you keep these straight and refer back to it when you're figuring this stuff out. All I did, and this took a little bit of work. I think you can use like an if-then statement or in Excel to do this, but I didn't want to spend time figuring it out. But if you think it's going to save you time, fine. Otherwise, what I just did was like, all right, I'm comparing, and it tells you what to compare. So compare similarities by proximity to tree trunks, which is either under maple quadrant versus away from the maple, or under beech from away from the beech. So first I kind of set up what I wanted to compare, right? Old wood forests. Site A I defined as maple on the tree. Site B is maple away from the tree. Same thing for the beech. And then I just kind of went through and looked at the data, and it was like, how many are there, right? So site A, how many are common to both under and away in maple, right? So I went back to my data. I was like, all right, let's look at maple. Sometimes it requires me to sort all this to look at it in a better way. But basically I'm looking at these 5, maple away, and then maple under, right? Just from looking at that, I can tell that all these species are in both sides, right? There's 1s. There's 1 for all, at least one of those species. So even if it's like, if it's 0, 0, 0, 0, 1, you would still count trout lilies being present in that section. All right. Whereas here, same thing. All these species are present in at least 1 of these 4 quadrants. So that means that all 5 of the species that I have, number of species that are in both is 5. Right? So then with B, how many are in site B but not site A? So that would be how many are here, right, but that are not here. In these cases it's 0. And it's the same thing for C. So the source and similarity index ends up being 1. Because they're pretty similar. All the same species are in both locations. Look at this equation, if you want to write it down, it's written for you, it's not written for you here. The general equation is, if you want to know how to write it in Excel, it's right here. So That's what the equation looks like in Excel. You guys all got that? Alright, moving on. So you do that same thing. You compare. You just want me to leave it on the screen?